Now about how remote sensing could assist in identifying high emissions from HDVs, heavy-duty vehicles, in Europe. And this comes up during the coffee break all the time, is how we find out and detect where vehicles are operating incorrectly on the roads. And we have Herbert Woopen joining us from OPUS Inspection. He's the EU representative of the company. And he describes himself not only as a convinced European living in Luxembourg and spending much of his working life in Belgium and Germany, but also very cares about Europe's future in terms of clean air, because he has 4 daughters and some potential grandchildren. So interested in how these technologies develop. He's been tracking technology in different applications, but is now responsible for the business of OPUS Inspection in Europe. And he's going to tell us more about the company, no doubt. But he'll be covering this topic about how we could possibly remote sense vehicles and how that could, I guess, advantage us in terms of the implications for eliminating and tackling some of the conspicuous cases or bad behavior by operators. So over to you. We look forward to your presentation, Herbert. The floor is yours.
Yeah, thank you very much. I hope I can present to you now remote sensing for the next 30 minutes as a truly disruptive technology for Europe at least, because in the United States it has been known for the last 25 years. I will tell you what remote sensing is about, what we're observing in Europe as reasons to get to grips with that technology. I will show you how it has been proven effective in the past in the United States. We will see how it compares to PEMS and to lab measurements and the potential future use of it. Well, just a few words about the company. OPUS Inspection is a Swedish-American company with a German CEO. It's purely an inspection service company. We even sold our equipment division, to be clear on that. We have more than 1,200 employees and are the market leader in the United States and Sweden, with operations in 22 of the US states and various other countries across Europe, Latin America, and Asia. Among this, the commercial hub for remote sensing in Spain, recently acquired. So what is remote sensing about? The measuring principle is infrared and ultraviolet light, which crosses the plume 100 times within half a second. The infrared measures HC, evaporative HC, CO, and the coarse particulate matter as a concentration of CO2. And the ultraviolet light measures the NOx, separate NO and NO2, and the fine particulate matter, because it has a wavelength of 230 nanometers, which is lower than the traditional green light, which is used for opacimeters. So the light goes across the street. It's returned by a corner cube mirror across the side, goes back into the analyzer in the same box. And at the same time, the speed, acceleration, and slope are measured in order to have the kinetic conditions. With light-duty vehicles, the number plate is taken, and you can take the typical mass from the registration data. For heavy-duty vehicles, it's necessary to go via a way in motion to know the load of the weight of the full lorry, because that makes a big difference for the vehicle-specific power at the moment of measurement. In the United States, the exhaust pipes often go up on the vehicle, so it's often measured both at the bottom and at the top for heavy-duty vehicles, because that is of special interest. I'm showing that to you. But the general takeaway for remote sensing is that it is an actual measurement on the road. So you measure vehicles where they pollute, and you screen masses of them. That's the specific advantage of remote sensing, not only single ones. It has been developed in order to enhance the inspection and maintenance programs in the US, which have been activated 25 years ago. The goal is to identify those vehicles with common maintenance issues that increase emissions. And while we have been applying that methodology over time, you see degradation of vehicles over time. You can analyze whole fleets of vehicles in particular metropolitan areas. So that is a very good basis to do data mining. Now, what is actually the reason we in Europe should care about remote sensing? Diesel manipulation has a long tradition. It has been going on in the United States, of course, as the country of origin of cleaning exhaust. Also, fraud has taken its inception, and the first big scandal was in the 90s, which was finished by one of the highest settlements of the time, $1 billion against 6 producers of diesel heavy-duty vehicles: Cummins, Caterpillar, Detroit Diesel, Volvo, Mack Trucks, Renault, and Navistar. Since then, other technologies have been used, so diesel particulate filter, exhaust gas, recycling, and of course SCR, but all have been tampered with. You have the example mentioned there is a fine of only $500,000 for a company called Edge Products in 2013 for having removed 9,000 diesel particulate filters. Europe, it's becoming fancy in Europe now as well, and it has become more known by the general public by a TV emission, which the German channel ZDF has produced. They went in a clandestine way to Romania and had somebody present himself as a truck owner who wanted to remove the SCR. It's all filmed. It's a nice film of half an hour, good fun. And it was no problem whatsoever to get that. And they were even so kind as to implement a Poland switch, as they called it, because the Polish, for certainly a good reason, are more aware than other parts of Europe that this exists. So when you approach, as such a driver, a Polish police patrol on the highway, you switch on your SCR switch, and the Polish have more difficulty in finding out that you are not using your SCR normally. So it's called the fairy tale of the clean heavy-duty vehicle. The film is available on that link. In Germany, road tolls are dependent on the emissions class of the truck. So these drivers pollute as a Euro 1 vehicle, and they pay the road toll as a Euro 6 truck. And specialists have calculated that that makes a loss to the German budget of 110 million euros. But it has become even worse. You can get it very easily on the internet. Just go to Amazon and look out for diesel emulators. It's plug and save. You just order it via Amazon, you plug it into your OBD2 connector and remove the fuses which I mentioned. That overrides the AdBlue system instantly, stops usage of AdBlue, and you have no damage to the engine, no negative effects to truck factory settings, no permanent change of settings, and to turn back to the original settings, just unplug. That's the one specialized for Volvo. There is an offer for any brand you can imagine. So that's the reason why we should talk about remote sensing more intensively, I think. Now, the historic examples. In Boston, environmentalists and people in general were complaining about the buses because they were so dirty. So the Massachusetts Bay Transportation Authority came to see us and asked us what they could do about it. We gave them 2 fixed installations in 2 of the depots here to measure constantly their fleet, and a couple of movable parts which are rotating among the other 6 depots. And that way, the mechanics learned to read the emission profiles of the buses. Here, for example, there was a very high HC curve on the left hand, and over the weekend they replaced the O2 sensor, and afterwards the emission curve was in order again. They have trimester reporting cards on that, which are still in use. That is 10 years ago now. And they put them onto the internet for many years. Currently it's still being practiced, but it's not so much more monitored in the live. In the newsletter in 2008, they were proud to show how the fleet had improved with these measures, with this increased awareness of pollutants. That's the NOx emissions. You see, after 5 years, it's just a small fraction of what it was in 2003. And for particulate matter, it's a little more, but still very considerable what has come down. Now the second example. At the Port of Los Angeles, people living close to the port were complaining about the bad air. And we set up the following exercise together with the University of Denver, which actually has developed this technology, Don Stedman, and has licensed it to OPUS inspection, and we are the commercial users of it. So we had this one station, which we've just seen at the Port of Los Angeles, and another one on road somewhere in the country where trucks pass after hours of driving, very hot condition. So at the Port of Los Angeles, something exceptional was implemented, a thermograph camera and urea tank detection in order to identify the trucks with SCR. And then the picture, the thermograph, showed that at the Port of Los Angeles, Polar, the average temperature of the exhaust was only 155 degrees Celsius, whereas at the Peralta weighing station, somewhere out in the countryside, average temperature was 225 degrees Celsius. That had the following result. Even though it was the same vehicle fleet coming by, you see in the blue sections, the Port of Los Angeles, very much higher emissions of CO and NOx, and the mean, on the right-hand side, the mean temperatures is the reason. So the reason was identified why the pollution was so high at the Port of Los Angeles. Consequence was that over time, trucks admitted to the port had to be more modern, had to have better pollution control, and you see there on the right-hand side in the columns the pollution going down considerably, at least by 80% or so for the smoke factors and a considerable part for NOx. Third example, that's a fleet emission characterization in the greater Vancouver Regional District. Over 2 months in the summer, on 24 different sites, 11,700 trucks were measured at the yellow sites. To concentrate on the second part of that chart, 3 heavy-duty diesel groups were identified. Those 2007 and older, they had high particulate matter, high NOx. Those from 2008 to 2010, low particulate matter, somewhat lower NOx. Those 2011 and younger, low particulate matter, mostly low NOx. So that was obviously the introduction of the diesel particulate filter as from 2007-2008 effective, and the selective catalytic reduction starting 2011. In detail, in percentiles, in deciles here distributed, you see that until 2008, or 2007, the NOx was quite high, and then 2008 it comes down somewhat. Only in 2011, with the SCR, it really comes considerably down to almost zero for a larger part of it. For the particulate matter, it's even more impressive. Starting 2008, flat, and what you see in the background are those, of course, who are the exceptions, who need to be detected, who need to be repaired, who have been tampered with, or whatever. So, considering the whole group of trucks which has been monitored, you see here the blue line, which shows those high in NOx, and the gray line, those high in particulate matter. And on the right hand, you have a red scale, which shows the percentage of high emitters among the measured vehicles. And there you see, starting 1997, it goes considerably down until 2007, 2008, and then again from the 10% or so, 2008, 9, considerably lower to 6% or so. So that also is the development we should wish for also in Europe. Next question. How does remote sensing compare with PEMS? For that purpose, a special setup was created at the US-Mexican border, at the Mariposa port of entry, where many supposedly dirty Mexican trucks come in. And they were first equipped here at Station 1 with the PEMS. At Station 2, they went over the way in motion. And at Station 3, there was a remote sensing device. And in order to have sufficient data for measurement, these poor trucks had to circle and circle and circle through the remote sensing device again and again with the PEMS mounted on them. And that is the result of putting the dots, the pink dots of remote sensing measurements onto the continuous line of the blue PEMS measurements. And these are quite impressive hits. If you sum that up as a correlation, it's also quite convincing, I think. Now, as an observation on the margin, in this exercise, 15% of the trucks created almost 30% of the NOx, and 10% of the trucks created 30% of the smoke. So also a field where one could act to take out the most heavy polluters. Next question, how does remote sensing correlate with lead? That's the setup where that was measured in Japan, by the way, a Horiba analyzer. And here you can see the device, the measuring device, and the sender of the light, and here the mirror for the remote sensing. So the exhaust fume went out here. It was measured both by the mirror and the remote sensing device and the Horiba analyzer. And that is the curve which turned out for a Mitsubishi Lancer. Also sufficiently close, I should say. So if the task now is to detect tampered vehicles, those who are supposed to have SCR and don't use it because they don't fill the AdBlue tank because they're manipulated, here is a graph which shows how precise the remote sensing methodology can discriminate. You have 97% of the vehicles, of the trucks here, 6.6 liter trucks, 2013 and younger, which are equipped with SCR, they turn out to have a NOx of less than 10 grams per kilogram fuel. And those who are older, 2007 and older, and do not have SCR, have conspicuous NOx values of more than 10, by 96% more than 10 grams per kilogram fuel. So I think that is sufficiently precise to sort out those who are cheating. And others believe the same. So the International Council for Clean Transportation, ICCT, recommends in an April white paper to introduce remote sensing programs at local levels to make sure emission components are not tampered with, and also to determine if particular brands or models have higher than normal failure rates, and then investigate what the reasons are. Also, the associations have woken up. CETA, you probably know, is the Association of the Inspection Companies, and CORTE, you may not know, is the Association of the Road Surveillance Authorities. They have formed a joint working group on initial roadside inspections because the EU directive on periodic inspections leaves some space to be filled. So they have drafted, or have written and decided, adopted guidelines for initial roadside inspections, and they've explicitly said at various places in these guidelines that remote sensing should be used to identify polluting trucks in order to pull them up and examine them further. That's not enough. Also, the legislator and the European Commission have joined the movement. So the European Parliament has explicitly said in its draft of the new type approval regulation that remote sensing results should be considered for further inspection. The European Commission even has said in its guidelines of January on the detection of defeat devices that remote sensing is one of the methodologies they recommend to apply. And the inquiry committee of the European Parliament into emissions in the European automotive sector went as far as saying that an EU-wide remote sensing network should be established as one of the consequences of the VW scandal. That gives me the opportunity to share with you a chart which a staff member of the Parliament has drafted and presented at the CETA conference a few weeks ago in Zagreb, a message to the automotive industry, those who have not yet understood. Bring your technology in line with the legislation we want, instead of trying to get our legislation in line with the technology you want. So they really mean it. It's time for a change of mentality. That's a nice picture to show it. So summing up, the OPUS remote sensing technology can monitor also in Europe vehicle emissions and their development over time on road. Has proven effective over the last 20 years in the United States to do it. It is crucial, we haven't talked about this, that the equipment is mobile in order to really screen whole vehicle populations. You can't get them all if you just measure at one point, you need many points. For example, 120 measuring points for a metropolitan area of 2.4 million vehicles. The technology has helped to expose Dieselgate via data from Europe, which have been transferred by ICCT to the US. And it is likewise able to prevent further defeat devices from manufacturers. And it will also be able to identify, of course, tampering by owners or others. So remote sensing can complement OBD inspection. It can provide surveillance for compliance testing of the whole fleet. It can help in enforcing emissions-related road tolls, enforcement of low emission zones in cities, and it can also very nicely accompany the success of possibly and hopefully upcoming retrofitting of older diesel vehicles. As I've read this afternoon, the German government is pressing hard the German manufacturers to do something now. And remote sensing is a technology which stops guessing, the guesswork about emissions. It's a technology to start knowing what happens on our street. Thank you for your attention, and I'm open to questions.
Thank you, Herbert. Any final questions for our speaker before we close? I'll start with a question. Herbert, you mentioned some US examples of remote sensing, the Port of LA and so on. Are there any existing uses of this technology in Europe that you're aware of by any city authorities or any groups?
There are several studies indeed. And the best example is the Zurich example. At Gockhauser Straße, AWEL, the respective environmental authority of the Canton Zurich, has been measuring with our technology over the last 15 years. It's all on the internet. You can see the population of the Zurich.
And do they use that for enforcement, or is that
No,
purely for
that's
measurement?
just for studying and showing where the problems may be.
Is the technology accurate enough for future enforcement? Could there be some consequence for vehicles?
Well, I think there is always some element of doubt still. I mean, if you have a precision of even 97 or 99%, it's not 100%. So I think it would always be a technology which says, you have to present your car to a garage, make sure it looks very conspicuous, fix it, or have it checked again. So it's a complementary technology. If you really want to examine in detail, put on a PEMS and drive 2 hours with the vehicle, and then you know, of course, all about this vehicle, whereas remote sensing tells you very much about the characteristics of a specific car type all across the fleet, or about developments under certain environmental conditions, for example, temperature or humidity, slope, whatever. So it may be used for enforcement reasons. If you have somebody coming into a low emission zone and he has high emissions, I mean, then you can stop him and check the vehicle as a police officer. But I do not see remote sensing as a technology which would immediately lead to a fine. Rather, the opposite is being practiced in the United States, which is also very surprising for European minds. They have exemptions from the duty to bring your vehicle to a garage for inspection when you are seen once, twice, or 3 times by a remote sensing device on road and your vehicle has been clean. And you get a letter from OPUS inspection saying your vehicle has been seen clean, please pay the fee for inspection, and you don't have to go anymore the 100 kilometers to your next inspection site. So that's so-called clean screening, and that's done for about 30% of the vehicles.
Wow, so that's widespread already, that system. Yeah. So any questions, final questions for Herbert?
Yeah, I have one for the US. Why there's EPA legislation in the United States is in principle for the whole of the United States. Why is it then it's the Port of Los Angeles and Boston Transport Authority, Vancouver Transport Authority? Is it because their voters or their people more sick or whatever, have more breathing problems than they do? Why is it not done on a national level?
Yeah, good question indeed. The US is doing these inspection programs just on a need basis. Yeah, they're saying in states where there's so much space, where there seems to be no pollution, the laws are theoretically in force, but we do not do anything to monitor it. But when there are problems, like in the Los Angeles region or in Boston, whatever, where you can see that the pollution is too high, then this state has to set up a program, an inspection maintenance program, to ensure that the pollution standards are being enforced. And then that has to be supervised, and the EPA then says, well, we'll monitor this also by remote sensing and see whether you're successful in doing it. So that's a quite selective approach, which leads to funny coincidences indeed. For example, in Texas, where they do have a need to do this, in Dallas, for example, then commuting vehicles come in from other states, not having been checked for years, yeah? And then they, of course, are being picked and they are banned from the region. They lose the...
It's quite clear. If
Yeah,
you drive
good.
to Los Angeles on the highway there, or if you drive through the Mojave Desert, you try to look nice, especially if you go down towards Mojave, there are like 2,000 wind generators.
Disperse. Yeah. Any final questions for Herbert? No, in that case, we should move on. So, Herbert, thank you for the updates, and I think we'll see this technology used more in the future, given the advantages. So, thanks for telling us what it can do.
Thank you very much.